So in this particular diagram, I want to show you a process called rifting. And rifting is what happens when a continent basically gets completely severed and split in two. So as that happens, rifting will continue and eventually you will get a fully established divergent plate boundary. So if you were to look in diagram A, as you can see, the two convection currents are moving in opposite directions. As a result, that's putting tension on this continent. And I like to think of two people with their hands on a big Turk bar pulling in opposite directions. First thing that's going to happen is that the chocolate is going to break, the jelly is going to stretch and thin, and eventually the big Turk bar will split into two. If we move to diagram B, a well-known place in the world where we can actually see this is the East African Rift Valley. So the convection currents are moving in opposite directions, and as a result, Africa is being split into two. So we will eventually have a plate boundary, a fully established divergent plate boundary right down through Africa, and that will separate the countries of Somalia and Sudan. Right in the East African Rift Valley, just to give you some perspective, the country that's right in the East African Rift Valley is a country called Ethiopia. If you go back to the big Turk bar analogy, it's basically pulled apart to the point that the jelly is really thin, and in this particular case the molten is able to burn its way up through and basically create a couple little volcanoes on the surface in the Rift Valley. And in the East African Rift area we can see Mount Kilimanjaro and Mount Kenya as just two examples of volcanoes in that particular area. It's almost at a point there now where it's stretched so far apart that the salt water from the Indian Ocean is coming in through the Gulf of Aden and also penetrating into this area, and we're getting a lot of evaporation of the water, leaving some really big gypsum deposits and rock salt deposits and sylvite deposits, which are evaporite sedimentary rocks that we talked about in the previous unit. Once this continues a little further, the East African Rift Valley will basically become exactly like we see in the Red Sea. So the Red Sea is in stage C. So if you were to look in the particular diagram here, the two sides, so in this particular case Saudi Arabia and Sudan, they're fully apart and the water is fully penetrated and it's actually a sea. And we have a fully established ridge with seafloor spreading taking place, and lava is pouring out of the volcanoes, creating new ocean floor all the time. And the convection current is taking one plate with Saudi Arabia one way and the other plate with Africa and Sudan in the other direction. And so the actual Red Sea is splitting apart at about 2 centimeters per year. And so we just basically looked at the rifting of a continent and how that went from being a rift valley all the way to a fully established divergent plate boundary. Now the Red Sea is a divergent plate boundary, but an example of where the divergent plate boundary would be even bigger than that would be like the Atlantic Ocean, where Europe is on one side and North America is on the other side, with the Mid-Atlantic ridge straight up through the middle. So there's no question the Red Sea is getting bigger and eventually may one day be the size of the Atlantic. Who knows?